My name is Alona. I was part of the KubeVirt networking team for about 5 years, up until a year ago, and I was also a KubeVirt maintainer. And Edward Haas.
Yeah, I'm the current KubeVirt network maintainer. We wanted to talk today about our beloved KubeVirt network plugins.
So before we start, can whoever of you that already familiar with KubeVirt, please raise their hand? Okay, nice. So I hope we will be innovative enough for whoever who is familiar and clear enough for whoever is not. Our agenda for today, first we'll start with some terminology and try to explain a bit how KubeVirt networking works. Then we'll go to real-life examples of issues that we have with our current KubeVirt networking solution and why we realized that we need more flexibility and to do some changes to our existing solution. And then we'll explain exactly the journey that we took and how we solved the issues we had. And hopefully will help you to understand what you can do to solve similar issues with your systems. So first of all, I guess most of you know, but just to be on the same page, what is Kubernetes? Kubernetes is an orchestration system that manages containerized applications. The minimal executable unit in Kubernetes is called a pod. A pod is basically a set of containers that share resources like network namespace. KubeVirt is a management system for virtual machines. But unlike traditional virtual machine management systems that you are familiar with, KubeVirt is actually an add-on to Kubernetes. KubeVirt allows to run pods alongside VMs on the same Kubernetes cluster and manage them using the same tools, and the VMs and the pods can communicate. Actually, the VMs are running inside the pod. We have a pod that is launching a VM. A bit more terminology, so it will be easier to explain how KubeVirt networking works. So basically, Kubernetes doesn't have a built-in solution for networking. What Kubernetes have is a specification that is called the CNI, Container Network Interface, and this specification may have multiple different implementations. Once a pod starts, Kubernetes invokes an implementation of this specification to set up the networking of the pod. So this executable that implements this specification will add the interface to the pod, will specify the IP address route and whatever needed for this pod to have networking. So we have a lot of implementations to this CNI specification. For example, there is SROV CNI if you want to add high performance and to add virtual functions to your pod. There is the OVN Kubernetes, which is the default CNI for OpenShift and is used for the management network of Kubernetes. Okay, so we have those CNIs. We can get networking to a pod. But the problem is that Kubernetes can run only one implementation like this, one executable to specify the network. But what if I have on the pod multiple interfaces and I want different types of network per each interface? So on one interface I want SROV, on another interface I don't need SROV, I want to use another CNI. So this is where Multus comes to the picture. Multus is basically a meta CNI. So when Multus is used, when a pod is started, Kubernetes executes the executable of multus, and multus in each turn is executing the plugin CNIs, the other CNIs that are needed for all the interfaces in the pod. So let's try to explain how KubeVirt networking works. Let's start from the basics. We have a node. The node is connected to the network. Then we have a pod inside this node, and we want to connect this pod somehow to the network. So as I explained, this is done by a CNI. It's not that the pod is directly connected to the interface of the network, but there is some magic the CNI does to make the pod go outside to the network. Then we have a VM. The VM is running inside the pod, and we want to somehow also connect our VM to the network. The pod already has networking, so basically what we need to do is to connect the VM to the pod network. And how do we do it? The way that we do it is called network binding. We in KubeVirt have different implementations that each one of them answers different needs for how we do those network bindings. Network binding is something complementary to the basic CNI that is configuring the pod networking. So we have some CNI that configure the pod networking. The pod has some kind of networking, and now we want to connect the pod to the VM. So here comes the network binding, and we'll now scan them and see what kinds of bindings we have.
Yes, so our main talk here is about the bindings. So we will go over them just to see the history, so we'll understand how we got to the challenge. So we started with to understand what does the binding contain, more or less. What parts does it contain? So it contains first the domain configuration. The domain in KubeVirt is libvirt, if anyone knows here. That's the part that's the hypervisor that emulates the VM. So how to configure the NIC, what is the characteristic of it, how it connects to the outside world, that's the NIC configuration. Then we have the pod network namespace configuration. For example, in order to, usually a VM is created in, as you saw before, but it has a tab device that represents the VNIC inside the guest, and that that tab device is connected through a bridge. So creating the tab, creating the bridge is part of the pod network configuration. And lastly, we have optional guest services that, or I will say, we have things running in the pod in order to serve the guest, for example, a DHCP server. So a list of how it started, like the binding in KubeVirt. It started with, I think this was the first one, the first binding, which is called slurp. Does anyone know slurp here? What does it mean? It's too old, that's why you have the skeleton here. It's old, no one uses it today, it's very slow, so we killed it as well. Then we had a bridge binding. The bridge binding was also very simple. It just took if you got an IP address, a pod with an IP address, it connected it to layer 2 inside the guest, and it just took the IP and put it inside the guest. That's basically it. It's the most high performance today, maybe after SRV, I would say. Then we said that we need to do migration for VM, which is pretty basic in virtualization. So the previous one did not work well with migration, so we had to do something new, which is the masquerade. The masquerade one is basically a NAT. And why is it allow migration is because inside the guest you have the same IP, so when the guest migrates, it migrates with the same IP, so it can continue working without a problem. And then we have this SRV one, which if someone needs real performance, then that will be his best choice if he has the money to buy the hardware. Then we had all the ones that I spoke until now, all of them were GA, I will say. We had They were considered production, and then we started to get requests, or we wanted to explore new things. So we started adding bindings that are not production level. We try to play with them and see if they can replace other things and solve other problems. So the first one was passed, I think. It's like an enhanced Slurp. It allows you to do whatever Slurp did better. Basically, you don't feel like your IP address, you don't feel the fact that you are now bridging something or from the pod side. And then we had the MacVit app. This was real hard to do, like asking AI to create a tab. It was very hard, by the way. Yeah. Alona succeeded. So MacVit app is, I guess, the second performant one after SRV because it creates the tab device on the node, and it put it inside the pod and then connects to it. So it's also experimental, and we are not, it's not GA in the product.
So as you can see, we had a long journey with the network bindings. The project, when the project is good and it rocks, comes more requirements, more use cases, and indeed, KubeVirt rocks. KubeVirt is a great project, and now I can tell it because I'm not part of KubeVirt anymore. And it is a really, really good project. It is a rising star. And when you have such a great project, you have a lot of customers, and you have a lot of external contributions from the community. And it is something that we really encourage and want. So as we grew, we improved even more the network bindings that we had. So we added IPv6 support to the Masquerade binding. Masquerade binding is our main binding. It's really important. We added IPv6 support to it. Then we also added the support of the Istio service mesh to the Masquerade binding. We also dropped from the Masquerade and the Bridge binding those bindings, their implementation needed some privileged capabilities like NetRow. So we changed the implementation. So the pod that is launching the VM won't need those extra capabilities. But with great power comes great responsibility. By the way, ChatGPT refused to generate a picture of Spider-Man because of copyright, so that's what we have. But imagine it is Spider-Man. So with great power comes great responsibility, and yes, the project grew. We want more contributions. We want to enhance the project, but we need to stand behind our code. Our code should be clean, nice, maintainable. We need to think about backward compatibility. We need to think about upgrades. We need to have a great test coverage to the code. Each new feature that is added, we need to think about all the other features, how it affects them. So yes, from one hand, we want contributions, but from the other hand, we can't approve everything and add any extension to the code base and like just say, okay, thank you, and add it, because we have a responsibility to our code. We need to keep it maintainable. So unfortunately, we could not approve some of very, very great contributions that we've got from the community. Like people from the community actually not just suggested something, they actually created the whole design and implemented great features that we really need. So we've got a full implementation of adding a binding for VDPA. VDPA is a technology pretty similar to SRV. We added a full implementation of adding to our code base network binding for VDPA. And we could not approve it because we thought that we cannot maintain it. But don't worry, we now have VDPA network binding, but in a bit different way that we will see. Also, for the other items that were closed, we now have implementation for it. But at that time, we could not approve them. So there was also a great suggestion and implementation of how to make the bridge binding working with migration. The fact that bridge binding didn't work with migration is a huge pain point that this binding had. And here there was proposed a solution, and not just a proposal, it was implemented, but again, at that moment we could not maintain it and it had to be closed. Same for MACVTEP binding. There was a suggestion of how to combine the bridge binding with the MACVTEP binding and create some more performant binding. Again, it was closed, we could not accept it. Multus, we in KubeVirt, our entry point to create a VM is the VM CR, and we don't expose all the possible fields that Multus can get. We expose just some of them that we found that are needed for the virtualization workloads, but we've got more and more requests from the community, but Multus supports it. Why don't you have it? Why don't you expose it? And we said, okay, it's not the main use case, and we cannot maintain it. And again, we could not, at that moment, we could not approve it. So this picture pretty much shows how Eddie and myself looked and felt at that moment, because we really wanted the contributions. They were great. They solved things that we wanted to solve, and real pain points. But from one hand, from the other hand, we had to keep the code maintainable. We could not make it grow and grow and grow and like lose control over the code. So basically, we understood that we need to stop and think what should be done differently, because we are in a situation that we get free contributions, really good contributions, from the community of things that we need, but we cannot approve them. So basically what we wanted is to have our cake and eat it too. And that's how came to the work network binding plugin. So we understood that what we need is to somehow make the network binding pluggable. So whoever wants to add its own binding or wants to adjust an existing binding can do it in his own repository, maintaining his own code base. Win-win. So now we'll take you to the journey of how we did it.
Yeah. So after we identify that this is more or less what we want, we try to think how we can do that. So the first step is to identify where we can plug things, like where are the integration points. That's where do we touch in order to make the binding originally. So the first one is the most trivial one, is the input of the user. The user inputs something that he requests, and then that request goes to the system, interpreted, and then applied. So the first input is we need to give a way for someone to create a plugin and then reference it that this is what they want, and then put some input in it. I will not get into the exact how it looks like, but more or less it talks about if before we had an enum of optional bindings, which you need to choose. Now you have it different. You will just reference a name, and that name needs to be registered at the cluster level. And at the cluster level, it needs to be registered there. That's the idea. An admin register the plugins, and in the VM that wherever you want to use it, then you reference it. This is how the registrations looks like. The second part is when the pod is configured. So we heard here about Multus. So what KubeVirt does is when you want a VM, it creates out of that request a pod, and on that pod it has some annotation that configures Multus. So, and maybe other things. So if someone wants to tamper with new possibilities, for example, add some new different, more multi configurations, for example. That the option to do it is when the pod is created. So for that, we have webhooks. That's a general concept in Kubernetes, that a webhook will just hijack for example, it detects the pod is created, the manifest is created, it hijacked it, it allows you to mutate it or validate it, and then returns, saves it in the database. So the third one was the configuration of pod network namespace. So inside the pod, you have a network namespace, and we want to change it. So, for example, you create, I think I said it before, we create a tap, we created a bridge, stuff like that. So in order to have external, until the plugins existed, KubeVirt main components did these changes. Now we allow it to, we say you can inject your own CNI. It's like you can create your own binary, and you can say in that binary whatever you want to change there, and then it will do the changes. So it's just a matter of injecting a CNI. The fourth one is creating a service, right? So we said that we have DHCP server to serve IP address inside the guest. So if we want is to add a service at the pod, so it will serve the guest. That is done using sidecar. So we allow someone to configure a sidecar, and the sidecar will serve that need. And the fifth one, I think this is one before that's the sidecar, sorry. So the last one, this is an example of how a sidecar, someone can write a sidecar. And the last integration point is the ability to change the domain. Like, right? We said that we have LiveVirt living there, so it's a domain. It has a configuration, how the interface looks like inside the guest, and how it connects. That part you need to do it by manipulating the domain configuration. So we have an integration point of if someone needs to do some special things to the domain configuration, they can do it.
So yes, we identified all the integration points. We even had ideas how to make each integration point pluggable. Then we extended our API to be able to register and use plugins, and we changed the code base, all the integration points, to support those plugins. But before we go to the community and tell them, okay, you can write your own plugin, we decided to be good and eat our own dog food first. So we have a lot of plugins. So some of them are basic plugins that are widely used, like Masquerade and Bridge, and we decided to keep them in our code, in our core code, and not doing them and not implementing them as a plugin. But we have more plugins that are less used, and those plugins, we moved them to be plugins. We implemented them as a plugin. So first of all, we cleaned the core code. We cleaned it. We removed a lot of bindings from it. Secondly, what we achieved is that we had a big library of examples of how to implement a plugin. And the third, and maybe the most important, is that we proved to ourselves that our new architecture is working, and we actually can create with it different kinds of network bindings. So now we have a set of examples and we have everything. Now the community can build their own plugins. So how is it done? How to build your own binding plugin? So first of all, when you start working on a plugin, I think the first point is the registration. The registration part is actually the part that forms the plugin. It forms all the building blocks, all the integration points. Each integration point is a building block, a part in the puzzle of this plugin. So the registration, we'll see later exactly what the registration contains, but the registration is done on the KubeVirt CR. KubeVirt CR is a CR that can be edited only by the admin. We don't want non-privileged user to be able to add whatever plugins. We want to have some control of it because they are adding CNIs that can modify the pod network, they can add sidecars. We don't want any unprivileged user to do it, so the administrator registers the plugin. Once the plugin is registered, VMs, VM interfaces can be assigned to those registered plugins. So here we can see that we have an example of KubeVirt CR with a plugin that is registered here. In this case, the plugin is one plugin that we had as a core in the past, and we moved it to be a binding plugin. So we can see that it is registered in the KubeVirt CR, and we can see that we have here a VM with an interface, and this interface is using this binding plugin. So let's try to see what are the registration parameters. Again, the registration parameters are exactly our integration points, and they are building blocks of the plugin. Not every plugin needs to use each of the building blocks. Some of the plugins need to configure the pod networking, some don't. Some of the plugins need to change the DOM XML, some don't. So here, the first building block is the CNI. CNI is basically something that is invoked. We have the CNI to configure the pod networking. If we need some more modification and it's not enough, we need to do some more modification to our pod networking, like adding a bridge, adding a tab device, whatever, we can chain another CNI to the default one, to the one that is configuring the pod networking. And what's important here is that this CNI is implemented by the developer of the plugin. It is his responsibility to maintain its own life cycle. It lives in his own repo. He needs to build it, he needs to deploy it, and all that needs to be passed here in the registration is the network attachment definition. Name, the network attachment definition is the standard CR that is used by Multus to configure the CNI. So here we pass the network attachment definition. We assume that the developer of the plugin took care of the whole life cycle of deploying it to the cluster and having the executable of the CNIs on the nodes. The second building block is the sidecar. If your plugin, again, it's not mandatory, maybe it needs it, maybe not, but if your plugin needs to modify, to do some modification to the DOM XML passed to libvirt, or your plugin needs to run some service like DHCP inside the pod launching the VM, then you can pass here the image of the sidecar. Again, the developer of the plugin is writing the code of the sidecar, the developer of the plugin maintaining it, building it, has it in its own repository, and just passes here the link to the image. Other building blocks, again, integration points that we have. In this case, we didn't make them fully pluggable. The developer of the plugin is not implementing them, but we added internal support for multiple options for those building blocks. So in case developer of the plugin doesn't want to implement his own sidecar to build the DOM XML for libvirt, we have already some built-in options that maybe be suitable for you. We have a built-in option for configuring a tab. We have a built-in option to configure a managed tab. So instead of having a sidecar, you may use one of our built-in options. Migration support. Also, we can specify whether our plugin supports migration or not. We can specify whether there needs to be done some post or pre-migration operation that we want KubeVirt to do before doing the migration. We also have some built-in methods that can be done pre-post migration, like link refresh. And also resource overhead. If your plugin is consuming a lot of memory, and we need to add more memory to the pod launching the VM. Then it can be specified in the plugin registration as well. So basically, the plugin registration and all its parts is formalizing what is your plugin and how it looks like and what building blocks it has.
Well, you took all the time. So I will try to be very short. We are currently having core bindings, which are the GA ones that are inside the core project. If there is a plugin that someone creates and it's very, very useful, and the community will think it's very important to take in, we'll take it into the core. We have the reference plugins, so people will see how to do them. And we have community that they can create plugins as they want. And we have already several that does them. And some of them are closed source and some of them are open source. Documentation you will find. There are problems with this approach, but I don't have time to talk about them. In general, I'm just a summary that we identified where it can integrate. We need to design it. We need to build examples, and you need to define a support model. And the support model is important in the sense that if there is a problem with a plugin, it should not fall on the main project. So if someone created a plugin, it collides with the main project, that vendor of the plugin should take care of it. It's important to take care of that part. That's it, sorry.
Questions?
Any questions? So can you give an example of some cool community plugins that came in for the project?
Yes, so indeed we had several implementations by the community of bindings. We had surprisingly 2 implementations of VDPA, of separate people that didn't know about each other's existence. So we have 2 plugins of VDPA. We have one vhost, right? Yes. So indeed it is used, and even I think in the KubeVirt summit there was a Chinese company that presented a binding plugin that they added, and we didn't even know about their existence and the fact they did it. So like they took it, they built it from scratch, didn't need our help, so like it works.
Any other questions? Okay, then thank you.